Welcome to Statistics for Surveys, Session 1 Basics, Segment 4 Measurement Levels, Ordinal. In this segment, we will be discussing the measurement level of ordinal. You should be familiar with the terms variable and values, and measurement level and nominal. In this segment, we will only focus on one term actually, ordinal. In the previous segment, we saw that the variables in gender, name, and educational program could be considered nominal, because their possible values do not have any logical ordering besides alphabetic. If you take a good look at the variables age category, opinion, and educational level, you notice that these do actually have a logical ordering. The remaining blue ones are all numbers, so they actually also have a logical ordering. I will first focus on these three green ones and why these are ordinal, and then I will also try to explain why the IQ, the Richter, and the birth year are actually also ordinal. Different textbooks would define ordinal measurement slightly different. My personal definition would be a variable for which the values have a logical order, but the difference between each value is not equal or can be perceived different. Now, the first three variables that I highlighted were opinion, educational level, and age category, and I would call these categorical ordinal because they still have clear categories. For the opinion scale, this could be fully disagree to fully agree. And if you look carefully here, agree and disagree are in a strange position. It's a little bit odd like this, so we would actually normally flip these two around, so it nicely goes fully disagree, disagree, neutral, agree, or fully agree. This makes it ordinal because there is a logical order of the possible values. The same goes for educational level and for the age category. Note with the opinion scale that the difference between fully disagree and disagree can be perceived differently by different people. And is the difference between fully disagree and disagree the same difference as between disagree and neutral? Because this is unclear, the difference between each value is not equal or cannot even be measured. These scales can also be completely flipped around, so instead of ranging from fully disagree to fully agree, we could have also ordered them from fully agree to fully disagree. The next type of ordinal, the numeric ones, are slightly more tricky because any number scale, for example age, Richter, position, IQ, weight, etc., will have an order because numbers are in order. And what makes these ordinal and not one of the other two, interval or ratio, that will be discussed in the next segment, is a little bit tricky, but it has to do with that equal difference between two consecutive values. For example, the position, if you have a running competition, then the person who is at the first position might only be a few seconds apart from the person who is at the second position, but who might in turn be a few minutes apart from the one who's on third position. So the 1, 2, and 3, the difference between each value for the property that they're actually measuring is not always the same. Sometimes this is very hard to find out if this is equal differences between two consecutive values or not. On the next slide, I'll show you why the Richter scale is actually ordinal and not interval or ratio. The same will actually apply to IQ, but I'll leave that out of this slide, otherwise it will take too long. To understand why the difference between a 1 and a 2 on a Richter scale is not the same as the difference between a 2 and a 3 on a Richter scale, we'll have to understand how the Richter scale is actually being created. The Richter scale measures earthquakes, the size of an earthquake, by using a seismograph, a particular type of seismograph, and looking at the readout of this, and in particular the amplitude. Now the amplitude does not correspond one-to-one with the Richter scale. There's a formula which is roughly that the Richter scale size is the 10th log of the amplitude. If we put this formula graphically, we see that, for example, the 1 on the Richter scale corresponds to roughly here, which is about 10 on the amplitude. So an amplitude of 10 will give you a Richter scale of 1. If we move 1 up to 2, then the amplitude has actually changed to roughly, or actually exactly 100. So moving 1 up on the Richter scale means an increase of the amplitude of 90. If we go one further up to 3 on the Richter scale, then the amplitude has actually gone up to 1000, which is a difference of 900. So hopefully you see that going from 1 to 2 on a Richter scale is not the same difference as going from a 2 to a 3 if we would measure this all by the amplitude. And this is why this is ordinal, because, or at least the Richter scale is, because if we move if we look at 2 consecutive values, the difference is actually not the same in the property that's actually being measured. To give you another example, the amplitude in itself is also ordinal, because it tries to measure the amount of energy release. And there's also a formula for that, which is roughly that the amplitude is the energy raised to the 2/3, which will look something like this. So if we now look at an energy release of 0 corresponds to an amplitude of 0. But if we move 20 up and then look at how much energy that actually corresponds to, that's roughly, let's say, 90. Then if we move another 20 up, then all of a sudden we end up at, let's say, roughly 250. So going 20 up in amplitude is a difference of 90. Well, if we do that again, then we have a difference of 160. So again, the differences between 2 consecutive values is actually not the same each time. That makes this, by the definition that's going to be used in this course, ordinal and not interval or ratio. For a nominal variable, we saw that the only thing we could do was compare the size of each category. So we could say, for example, that there were more males than females. For ordinal variables, we can of course still say the same thing. We can still say, for example, that there were more people who said that they fully agreed than those who only agreed. However, with ordinal, we can also make computations about less than or more than. We can say, for example, that 50 people said that they disagreed or even fully disagreed. So that would then be the combination of fully disagree and disagree, and that still has a meaningful interpretation. However, we can still not really perform any mathematical operations, because the most basic ones, addition and subtraction, will actually not work, because the definition of ordinal says that the difference between 2 values is not always the same or not perceived the same. So we can't really say anything about fully disagree minus disagree equals, well, would that actually equal then neutral? It's hard to tell, or it's impossible actually to tell. So therefore, with ordinal, we can still not perform any meaningful mathematical operations. So it will be in the next segment that we finally see a measurement level where those actually do come into play. Some textbooks will actually see numeric ordinal variables such as IQ or the Richter scale as an interval variable and not so much as an ordinal variable. The same goes sometimes for those fully disagree and fully agree scales. If I would have a 5-point scale, most would still consider that ordinal, while if we would have a 12-point scale or even a scale on 100, then it might be something said to consider that as an interval scale. So it's not written in stone anywhere that what an ordinal variable is, and if you perceive a numeric ordinal variable as an interval variable, that's completely wrong. It really is something to think hard about when you're going to perform statistical analysis, if it's okay to perceive it in your case as an interval variable or not. So be a little bit aware of this in future segments, or especially for your own research.